All right, in this video, I'm going to be going over evaluating piecewise functions. And you'll look at them from a graphing and a function point of view, so you'll see both of them. So let's just look at a graph to start. Those are always a little bit more straightforward than the functions. From a graph, the numbers will be pretty easy to calculate because you just pick them from points. So let's look at this example here. We want to know, what is f of -3? So we'll go to -3 on the number on the x-axis, and we'll find the line that it meets. And in this case, it's going to hit there right at the y value of -3 as well. So we don't actually have to do any work. We just got to find it on the graph. See if you can do the other four. Pause the video, or then after you unpause it, you can check it. All right, hopefully you had a chance to test these ones out. So let's do the other four. F of -1. Now there's an open circle below it in the red graph, and there's a closed circle above it in the blue graph. Well, you have to pick the one that's closed circle, because this is technically not a point. F of -1 is not defined down here, but it is here. So that value, it looks like it's going to be 2. So pick the closed circle. All right, f of 1, well, it looks like it's a little bit above 2, so I'm just going to eyeball that and say around 2.5. We'll say approximately 2.5, because I'm not 100% sure that's what the number is, but there is no discrepancy in terms of open and closed circles, so I don't have to worry about that. F of 2, you have a closed circle up here and an open circle, so you want to go to the closed circle and report that y value, which is 5. And f of 100 isn't even on here, okay? But I know that f of 2, well, that's up here. F of 3 is down here at -1. F of 4 is at -1. F of 5 is at -1. So hopefully you've looked at that pattern and you figured out that that graph's going to keep going on forever no matter what x value above 2 I plug in. So I know f of, 7 is going to be -1. I know f of 8 is going to be -1. F of 8, not -8. And so on. So f of 100 is also going to be -1 because of that arrow going to the right. Now the ones that we have to do a little bit more work on are piecewise functions where the function is given and not the graph, because we have to actually plug the number in and figure it out. And you can do this by hand. You can use Desmos to assist. Sometimes it's more of a time drain than it is worth it. But I'll show you, at least for one of them, how you can do it if you want to try that route. So let's look at this function. We have a piecewise function. We got 3 different pieces, 3 different domain restrictions. Let's start by figuring out where we're going to plug in all these values. So g of -3. If I look over here in my domain restrictions, -3 on a number line would be, well, it would be less than or equal to -3. So since -3 fits in there, I'm going to plug -3 in for the x's here and there. So we're going to want to do that. You probably want to use Desmos to assist in plugging in, but it's basically going to be -3 parentheses squared minus 3 times -3 plus 2. So if you want to do that by hand, you can. That's going to be +9 plus 9 plus 2. So it should be 20. But we can certainly verify that. So let's pull up Desmos and just double check our work's right. We don't want to have calculation errors on these. So parentheses -3 squared minus 3 parentheses -3 is 18, and then plus 2. So we're good on that. See if you can figure out the other 3. Pause the video and try it on your own. All right, hopefully you've had a chance to pause it and try number 2, 3, and 4. So let's check those. G of negative 2. Now on a number line, negative 2 is actually above negative 3. So negative 2 would be greater than negative 3. So negative 2 is going to fit in this domain restriction, which means negative 2 is going to get plugged in there. So let's plug that in. 4 times negative 2 minus 12. So 4 times negative 2 is negative 8. Negative 8 minus 12 is negative 20. And we'll go ahead and check that too. All right, answer checks. Number 3, G of 5. Well, 5 pops up here and there. So this would have to be less than 5 for it to be plugged in here. So I can't really do it there. This one says greater than 5, not greater than or equal to. So we kind of have a problem because on this graph here at 5, I can't really plug in anything for there or there. So in that case, if you were stumped on that, if you have nowhere to plug it in, you say undefined. Nowhere to plug in just means undefined. You don't have an output. And then lastly, if you're throwing a number at the front of these, that number is going to get multiplied by whatever you get here. So you figure out this number first. And of course, 7 is greater than 5. So we're going to plug in 7 into the one with the absolute value. So that's going to be the absolute value of 7 plus 2, which is 9, minus 6. So 9 minus 6 is 3. But that's not the end of your problem because G of 7 is 3. This is 4 times 3. So that's going to give you 12. So undefined for 5 because it doesn't exist. 20 for negative 3 and negative 20 for negative 2. We can check that last one too since we want to be consistent on that, but we cannot check this one here because there's nowhere to plug it in. So G of 7 would be absolute value of 7 plus 2, which is 9 minus 6. And then we would do 4 times 3 to give you 12. That's essentially what we're doing on these problems. All right, so the last problem is the same absolute value functions, a little bit more involved because we have two, not absolute value, we have two piecewise functions split up. And so you got to read them carefully because they'll be named different functions. This one's named f of x, and this one's named g of x. And we want to know which one gets plugged in where. So if it says g of a number, we have to look at the function that represents g. So let's do that. In this problem, it says g of 0. So if I look at negative 5 as my cutoff, anything less than or equal to negative 5 would be able to plug in the top one, but that's negative 6, negative 7. 0 is all the way up here. 0 can't get plugged into that one. So we know that 0 is greater than negative 5. In fact, we know that 3 is greater than negative 5. But the issue is we don't have an x to plug in, right? We just have a number. So what is your output in that case? What we can do to visualize what's going on is maybe just look at a graph of this one. All right, I didn't graph the last function, but if you throw these two graphs in, f of x equals negative x plus 3 squared, and then you do your squiggly brackets, x is less than or equal to negative 5. And then this one is f of x, or g of x equals 4. Squiggly brackets, x is greater than -5. So just kind of looking at these graphs, if I zoom out, this is like a parabola that just gets cut off here. And then anything greater than -5 to the right is going to be your function. But you might notice that it's just a constant function. It does not have a slope of anything but 0. No matter what I plug in for x, my y value, my output, is still going to be 4 because there's no variable, so it's going to stay 4. So your output is 4 when I plug in numbers greater than -5. So f of -4, f of -3, f of -2, anything higher than that is going to be 4. And that's just going to be a constant line. Okay, now let's look at some of the other ones. F of -3. Well, this one's g, so here's f. -3 on a number line is to the left of -2. So -3 is less than -2. So I'm plugging in -3 here. So that's -3 to the third power minus 4 times -3. Now, if you're not familiar with how to raise to a third power, that's -3 times -3 times -3, but mind your signs, because that's actually going to be a negative because there's 3 negatives. So it's -27, and that'll be plus 12. We can check that in the calculator as well. So let's go ahead and do that. Parentheses -3 raised to the third power minus 4 times -3, and that's going to give us -15. See if you can pause it and try to get the other ones. Okay, excellent. So let's check these. We'll use a different color. F of -2, -2 is equal to -2, so that's going to get plugged in here. So it's going to be 7 minus 6 times -2. Six times 2 is 12, and they're both negative, so it's really 7 plus 12. That's going to be 19. You can check that with the calculator. I'm not going to check that one. And on the last one, g of -5. -5, well, this is g. See, you got to be careful of that. And -5 is equal to -5. So -5 gets plugged in right there. Now, there's a lot of negatives out here. So we got to really be careful how we input that. I would type it into Desmos like this if you're going to use Desmos. But that's going to be -5 plus 3, which is -2 squared. Now, when you square a negative, you get positive. So that's going to be +4. But then that negative is going to turn it back into negative. So your answer should be -4. I do want to go ahead and check that one. So negative, parentheses, -5 plus 3, close parentheses, squared. And there is your -4. All right, one more to go over this one. Again, it's the same two functions, but now we're kind of putting them both together and we have one statement. So use what you've learned to try this one on your own. Okay, be very careful with your signs, what's going to be plugged in, how to address these numbers on the outside. So see if you can try this on your own. And we are going to, you're going to pause the video and try it. Then you're going to unpause and try it on your own with me. All right, my friends, let's see what we got. So 3 times f of negative 2. F is over here. Negative 2 is equal to negative 2. So f of negative 2 is going to be 7 minus 6 times negative 2. I think we did this one on the past problem, so that's going to be 7 plus 12, which is 19. So 3 times f of 2 will be 3 times 19. So that's 20, 40, 60 minus 3. That should be 57. So I know that this first chunk right here is 57. Okay. Now let's go over to this one. Hopefully you've tried this one too. G of negative 5. Well, G's over here. Negative 5 is equal to negative 5. So it's going to get plugged in there. We did this one too before. So G of negative 5 is equal to parentheses, negative parentheses, negative 5 plus 3 squared. If you add those together, you get negative 2. Negative 2 squared is 4. With the negative outside is negative 4. Then we have to apply the 5 with it. So 5 times all that, that's this over here, is going to be all this times 5. So negative 4 times 5. 4 times 5 is 20, so that's negative 20. All right, so we got those separately. That was a hard one because you had a lot to do with it. But now we're going to add those numbers together. So our final output is going to be 57 plus negative 20, which is 57 minus 20, and that should be 37. Well, that was a lot of work, but you stuck around and I appreciate you doing this. So please complete the rest of your assignment and reach out to your teacher if you have any questions on it. You have a good one.